we'll just riff and then I'll pull up the announcement sides and you go. Oh, we should do what we're drinking. Oh, we're live.
We are live.
Behind the scenes things. So, howdy everyone. Welcome to Astronomy on Tap BCS virtual edition number. You know what? I don't really know, but
27.
27. Okay, thank you. Wow. Okay, we've been doing this. We're getting along. We're getting along. And also getting hang of the virtual stuff. Anyhow, I am MC M33.
And I am Blue Moon Skater Girl.
Love it. What are you drinking,
Welcome.
Skater Girl?
I am drinking Texas's very own Hopadillo.
Oh, I can. Up, there we go. There we go.
Yeah. What are you drinking?
I am also drinking a Texas beer.
Nice.
I can't do this. Crawford Bach. There we go.
Cheers to that, and cheers to everyone that's joining us and drinking with us.
Thank you all for tuning in. I suppose you could also say coming up, but tuning in seems more apt for this medium.
Zooming in for us.
Zooming in. There we go.
Okay.
The usual. First, we have our announcements.
All right. So welcome to Astronomy on Tap number 27. We are doing trivia this evening, and just a reminder, this is going to be in a Google form, and the winners will be emailed, and you're going to get some prizes. So make sure to fill that out on text.ag/AoT trivia, and learn more about the universe with us based on this trivia.
Yeah, we will go through the answers at the end of the program. Next, the usual, like and subscribe for more great content. You'll probably get alerted when we go live for these. And yeah, just help us with the YouTube algorithm things.
Subscribe. Okay, and also while you're at it, follow us on social media. So we have a Twitter and a Facebook and an Instagram. On Twitter, you can follow us at AoT_BCS, and then Facebook and Instagram, it's going to be AoT BCS. So we will keep you updated on our events, our times, and our meetings in the future. And also, you can check out our website, which is astronomyontap.org/events, and you can also find out about our events there. So make sure to give us a like and a follow because we appreciate it and we're growing. So yeah.
And at the bottom link, you can also learn about Astronomy on Tap events that are happening all over the world at this point. Astronomy on Tap has gotten very international.
It's everywhere, yeah.
So as fun as doing this on Zoom can be, we do really miss our usual venue, the Grand Stafford Theater. So to support them in these times, you can Venmo at Jose-Quintana-20 and put Stafford Tip in the description so he knows what it is. Please tip your bartenders like this. We do miss them, and we really look forward to going back there, fingers crossed, soon.
And also you can support us, the grad students that are making this possible. So please, if you are able to donate, you can do this on Venmo or on Cash App at AoT BCS. And if you donate $15, you can get this really awesome, cool shirt with a little space girl on it. So make sure to help us out. We appreciate the help and we just love doing this. So we, please keep supporting us if you want to see more.
Yeah, our next event will be on September 16th, the third Wednesday of the month. Again, they keep getting closer to 14. I don't really like that. But anyhow, our next event will be on September 16th. Subscribe to our YouTube channel if you would like to be notified.
Oh, and we have our live chat, which is awesome. We love seeing what people are saying to each other about our speakers, just really creating a discussion group. And you can also put your questions there so we can ask our speakers at the end of their talk. So make sure to ask us whatever you want.
Yeah, and is this the last slide? This is the last slide. All right, we're gonna get right into it.
Okay, so let's present our first speaker, Gesa Chen.
Hi, there you go.
Hi.
So Gesa is a second-year graduate student at Texas A&M, and boring fact about Gesa is that he really likes spicy food. So
I can relate.
that's awesome. I'm really bad with spicy food, but welcome, Gesa. We're really excited to hear your talk.
Howdy, everyone. Tonight, I would like to introduce some special telescopes on the Antarctica. So firstly, here we come the largest telescope on Antarctica, and it is called South Pole Telescope. Actually, it is a radio telescope, but we still regard it as a telescope. Its diameter is 10 meters, which is the largest in Antarctica, but comparing to other radio telescopes, it is quite small. So that means using such an individual telescope, we cannot do many science. However, when we can use many radio telescopes together, we can do something special. And for the South Pole Telescope, it was an important member for the project Event Horizon Telescope. Before I introduce the Event Horizon Telescope, I would like to start from a normal optical telescope. And here it is an optical telescope called the Giant Magellan Telescope, which will be built at Chile in next few years. And if we take a closer look, between these telescope mirrors, there are gaps. And at a long time ago, our scientists have proved by theory and demonstrated in experiments that the resolution power of a telescope is dependent only on the size of telescope. If we can draw a circle to include all the mirrors into that circle, the diameter of that circle will decide the resolution of that telescope. However, if there are some crannies or some gaps between these mirrors, it cannot affect the resolution power too much. So, there come some very ambitious scientists, they suppose. Maybe we can connect all the telescopes all over the world together and regard them as one telescope, but with really large gaps between each other. Can it serve as an effective telescope as the Earth size and have a super high resolution? And the answer is yes, but it is only for radio telescopes. And they tried and they really built such a telescope, and they called it Event Horizon Telescope. Here, these are the member telescopes that contributed to the Event Horizon Telescope, including our South Pole Telescope, which is at here. And thanks to the location of South Pole, it is the furthest place, so it really expands the effective diameter of our Event Horizon Telescope, make it much more clear to see our stars. And as long as we have such a telescope, we choose a special object for our newly built Event Horizon Telescope, and that is a galaxy called M87. It is an optical image of galaxy M87, and we can see there is a blue jet emitting out of the galaxy center. And a long time ago, scientists have proved that at the center of this galaxy, there should be a black hole. When that black hole tries to swallow a gas, half of that gas will be swallowed into the black hole and never emit out. But the other half of that gas will be stripped away and eject along the spinning axis of that black hole and form that blue jet here. So our scientists suppose maybe we can use our Event Horizon Telescope to look directly at that black hole and to see if there are really some gas surrounding that black hole. And yes, they found this donut-like structure at the galaxy center, and this luminous yellowish light comes from the hot and dense gas rotating around the black hole. And the center, it is the event horizon of black hole. So according to, well, Einstein, the black hole mass can define the radius of event horizon. And when something falls into the event horizon, it cannot escape out, even including the light. So the center of this bunch of stuff is completely black. And from our image, well, we did some calculation, and yes, Einstein was true about the radius of black hole and its mass. So the next, we would like to back to some normal optical telescope. And here, it is a small telescope. We call it CSTAR, and its full name is Chinese Small Telescope Array. This small telescope is located at the highest mountain of Antarctica, which is called Dome A. And the telescope itself looks like this. You may wonder, it does not look like a normal telescope, because a normal telescope will be on a special base, which will allow our telescope to rotate around and point at different stars. But this tripod apparently cannot have such function. And yes, you are right. This telescope can only stare at a certain region of the sky. Although in many previous studies that Antarctica is a very extreme place, the air is extremely thin and the water vapor in the air is extremely rare. And when putting a telescope at Antarctica, especially at the highest point at Antarctica, it will look like the sky very clear, almost like we are at outer space. However, the humidity in Antarctica is still very high, which means the ratio between the water vapor and air in the atmosphere is still very high. And that means when temperature changes drastically, especially when it's morning and came to the night, our facilities will be frosted by ice. And if our telescope is movable, it will finally get frosted by ice and we cannot move it anymore. So within such a small telescope, everything cannot be moved, but it still serves as a telescope. And we even designed 4 mirrors for such a small telescope, and each mirror observes a star in different colors. So our CSTAR telescope observes a special region on the sky called the celestial South Pole, which is at here. Because Earth is rotating, when you take a random camera or maybe a telescope to observe a certain region on the sky and take a long enough exposure, you will see star tracks like shown in the other region of this figure. But for the celestial South Pole, the star in that region do not move really far away in a given time. So when we're doing observation at this sky region, the stars are unlikely to be contaminated by other stars. So we are still able to do some science. Because our telescope is small, we only focus on some bright variable stars, and here we show some light curve for these bright variable stars. And we can see the luminosity changes with time in different patterns. And furthermore, we try to find a extra solar system planet when the planet is between the host star and ourselves. We can see a part of the light from the host star is barricaded by the planet and luminosity dropped a little bit. But when the planet moves away, the luminosity back to normal. So as a successor of the CSTAR telescope, our Chinese scientists planned to build 3 telescopes with larger scale and with movable compartment and with heating unit. And they are called Antarctica Survey Telescope 3. Because we plan to build it with 3 telescopes, and the first 2 are already in Antarctica, but the third one is still at factory. So for this series of telescopes, they are still focusing on the variable stars and extra solar system planets, but with a better image quality, and they can see more of these kind of objects. I would like to show more results for our Chinese telescopes, but unfortunately, the best or the most paradigm-like science results do not come from Chinese scientists. It comes from a French telescope called PAIX, and its full name is called Photometer Antarctica Extinctor. And the telescope itself is shown in this figure. To notice, all these compartments for this telescope are purchased from the store, maybe online, maybe offline, but they are still consumed from the market. Like the previous telescopes, which are specially designed and constructed in laboratories. So this telescope's diameter is about 0.4 meters, and it didn't do much, but only observe 1 variable star, which is shown at here. So French scientists use such a small telescope to stare at a star at the beginning of the South Pole winter, and they observe it. The star changes luminosity in 1 period, and in 2 periods, in 3 periods, and finally in its 150th period. Then they plot the light curve 1 by 1, period by period in this figure. And we notice that the maximum luminosity of each period is also changing with time, and it seems to have the second period for such a variable light. Such a discovery is impossible at any other parts on the Earth than Antarctica or Arctica, because we don't have a polar night. In the polar night, especially in the polar night, when winter comes, the sun will never rise until the spring comes. And that means we can turn our telescope on for a whole, nearly half a year, and to do a very consecutive observation. Alternatively, it is still possible to observe such a star at outer space using space telescopes, but apparently space telescopes are much more expensive than such a tiny and purchasable telescope. Finally, I would like to introduce some logistics about how to maintain a telescope at Antarctica. Before I came to Texas A&M University, I was studying at Purple Mountain Observatory in China. And that is the institute where the CSTAR telescope and the AST3 telescopes are tested and constructed. After the CSTAR telescope is decommissioned from Antarctica, it is transported back to China to our laboratory, and we can really touch it in person. So here it is the CSTAR telescope, but with only 2 of its mirrors. And we try to mount it onto a normal base for a telescope. So now it can move its direction around to see different stars. And all these supporting facilities are as of it is in Antarctica. And in this container, there are the generators to predict electricity for our telescope. And in this container, there are the data storage system to store the image from our telescopes. And there is a tiny mushroom-like antenna above this container, and it is the iridium satellite antenna. When the telescope was at Antarctica, we can use iridium satellite to communicate with our telescope and send a command. So inside these containers, this is the data storage system. Each time when the Antarctica summer comes, our scientists will travel to Antarctica and swap all these disks inside the data storage system and train them with new disks while bring the old disk back together with data. And this is the image for the generators. Unfortunately, we are still using diesel to produce energy, which is, well, unfortunately not very environmental friendly. But during Antarctica summer, when the sun is still above the horizon, we can use solar panels to produce energy and charge some lithium battery. And most important part, as I have said, the facilities at the outdoor Antarctica are very easy to get frozen by ice. And that is especially true for our telescopes. So to handle such a problem, we tried to make a plating at the front glass of our telescope. When the telescope gets frost, when the front glass is covered by ice, we will heat the glass up and melt the ice so we can start our observation. And these pictures are our telescope trying to observe a galaxy with a changing source near this galaxy. This image is from Hubble Space Telescope, which looks very decent, and every stars are resolved. And this image is from a telescope, a 1 meter size telescope at Chile. And all these stars are still quite resolved with good quality. But for our Antarctica survey telescope, the AST3, the second one, the image quality were actually not so good, because at that time we are running out of fuel and the mirror is unfortunately covered by ice. And unlike the South Pole telescope and the photometric Antarctica extinctor, these observatories are properly maintained by personnel even during the Antarctica winter. Besides, these 2 stations have their airports. When necessary, personnel or some facilities will directly go to the observation from other stations, which is really fast. However, for our telescopes at Dome A, it is completely automated and no one will be at the observatory during the Antarctica winter. And during every summer, we will try to carry facilities and supply using a ship, travel from China to Zhongshan Station. Then our scientists will drive the dragger to carry the telescope or any other facility or any supply from Zhongshan Station to Dome A. And such a journey will take 21 days. And after they have repaired the telescope, they will come back to Zhongshan Station and take ship back to China. So that's really a long journey. And unfortunately, because it is still a startup project, we didn't attempt to build our telescope. We didn't attempt to build our airport near our observatory. So sometimes, due to the difficulty, we may not maintain our telescope annually. Especially this year, because of the coronavirus, we even didn't send any ship to Antarctica. So it is very difficult to maintain such an observatory at Antarctica. And according to a Japanese astronomer, actually an astronaut who has both traveled to outer space and Antarctica, he once said, Antarctica, he took several hours to the outer space while he took a month to Antarctica. So the Antarctica is a place further than the universe. And last year, there is a Japanese animation with such a title and tells a story of high school students going to Antarctica and helping to do some science research. It is really a moving story, and I was really moved because it notified me that there are still many young people concerned about astronomy and the science in Antarctica. Maybe in the future, there will be astronomers or even scientists and make Antarctica really a place for proper astronomical observation. So I leave this slide as my ending slide. Thank you for your listening.
Right. Thanks, Gesa. That was really cool. And now I have an anime recommendation.
Oh, yeah. That is a high quality animation.
So we do have one question. This one comes from Dark Matter Dude, aka Alex Riley. What's your favorite telescope on Antarctica?
I guess it will be the upcoming telescope, which is called K-DUST, purely because it is the largest telescope even planned to be built on Antarctica. Its diameter will be 2.5 meters, and if it is properly maintained, it will beat many 6-meter sized telescopes.
Oh.
But it is still on the air. We are not really deciding to build it.
Cool. This next one comes from the chat, JHC. I know who that is. What happens if you need to do maintenance on the telescope over the Antarctic winter? Are there any astronomers or engineers on standby to go if needed, or is there just nothing you can do?
For our Chinese telescopes, unfortunately, we can do nothing. And there are many times I witnessed at the almost August or July, which is at the middle of winter, the telescope just run out of fuel or come into some trouble, and we can only wait for the next year if our scientists will go to the mainland to repair the telescope.
Okay.
This can happen mid-observation, where you break down.
When the telescope is struggling, we will notice, because every day we will have my classmate to take care of that telescope.
Got it.
And when it's in poor quality, we can see it from its images.
Do you want to visit these telescopes?
Of course I want,
Probably
but
so cold.
Okay, this
well, I'm still in America, and in a foreseeable future, due to the virus, I may not that be easy to go back China.
We'll have to wait and see. And then you have to take pictures. And send it.
Yes. I guess, well, we're hitting 7:30, so.
Thanks again, Gesa.
Yeah,
that was
thank
an
you. That was a
amazing
great
talk.
You're welcome.
All right. Next up, we have a segment that we don't usually have every month. It is We Got Published. And this month, we will have Dark Matter Dude, aka Alex Riley, with a very triumphant yeah, because publishing papers are cool. I'm sorry, I'm overexcited. But anyway, take it away, Alex.
Okay. Hi, everybody. So yeah, my name is Alex. Since this is Astronomy on Tap, I'll introduce my drink. I'm drinking what's called a Moby drink. There's a Swedish fish. It's a drink. Cackle. I'm assuming everyone's laughing, even though I can't hear you. Yeah, so I'm going to talk about a paper that I am second author on that just got published. So the long title, the sciencey title, is a chemodynamical link between the Yole stream and NGC 3201. Now, the last sciencey title, the fun title, my version of this title, is, hey, look, these stars match that clump of stars over there. Neat. So we're going to talk a little bit about that and how we sort of came up with this paper and sort of what the result is. The Yole stream that the original title is referring to is what's called a stellar stream. So when a galaxy or a clump of stars that's called a globular cluster kind of gets accreted or falls into the Milky Way, and after it passes by the galaxy a couple of times, eventually it starts getting pulled apart, basically, because the gravity that's binding the object together isn't enough to overcome the tidal forces of the galaxy. And so it gets pulled apart. There's a leading arm and a trailing arm that kind of traces out the orbit of this dwarf galaxy as it's orbiting around the bigger galaxy. And so lots of these things have been found. And the result is that all across the sky, there are just these streaks of stars that are all moving across together in the same motion, and so these form these structures called stellar streams, and we can use these to probe where the matter or mass is in the Milky Way, and we can also use it to probe how the Milky Way has formed, because one of the big ways that the Milky Way sort of gains its mass is by accreting these tiny things along. So that's why we're interested in stellar streams. That's why we're studying these. Now we're focusing on one particular stellar stream, and with a prior study that I worked on, one of the kind of side results of that was that this stellar stream was very closely associated with a globular cluster. So if you take the globular cluster, rewind its orbit backwards in time, it overlaps with this stellar stream on the sky. And so using that orbit, I picked out stars that were consistent with that orbit. And we tried to figure out whether or not the stars in this stream were the same as the stars that were in the globular cluster that's in the lower right-hand corner. There's a really nice Hubble picture there. So the way you do that is you try to figure out the chemistry of those stars. It is the amount of iron and sodium and nickel consistent between these two structures. So to make that measurement, we had to go for a drive. We drove from Bryan College Station all the way out to West Texas and McDonald Observatory. That's shown here. We took observations with the telescope that looks like this, and you can see that McDonald Observatory truly is in the middle of nowhere. You really have to get away from all the city lights to make these types of measurements. Here's the telescope that we took a picture of. It's this massive, beautiful chunk of nuts and bolts all put together with some mirrors. Here's the control room that we used to steer the telescope around. But McDonald's actually a very interesting telescope in that you can automatically tell it where to point, but there are sometimes certain ways that if you move the telescope over the course of the night, you can actually scrape the telescope against the arm that's holding it. And so in order to make sure that doesn't happen, I had to go outside in the freezing cold because it was during the winter at very high altitude. So it was cold. And I had to push the green button to make this, to tell the telescope, it's okay, you're not gonna hit anything if you keep moving. And if it was about to hit something, I had to press the stop button immediately. I had to do this because I was the younger of the two observers. And it's also dark, so they had to use these creepy red lights to navigate around because the red lights interfere with the telescope less. Yeah, so that was the whole thing. But eventually we get data. And the answer to this question was, yeah, the stars that are in this globular cluster, so the gray points here, their chemical signatures, their iron, magnesium, silicon, are actually consistent with this big stellar stream that was discovered earlier that we took observations of to confirm whether or not these were the same things. So that's really cool. And now this is one small step in the broader picture of how we're trying to reconstruct what's going on with the Milky Way and how it gained all of its mass. So yeah, that's what we published this month.
Yay, congrats!
It's really cool. And seeing the control room, I think, is always really impressive because most people don't know what we actually look at. And we're actually in this room that's not super close to the telescope, just staring at a bunch of screens. So.
Yeah. We did get one question. This one's from Justin Keeney. How long does it typically take stellar streams to orbit the galaxy?
Yeah, so that's a great question. Typically, how long it takes them to orbit is maybe like, it depends on how far out you are. So closer things move faster. But typically you're looking on the scale of kind of like half a gig a year or 1 gig a year. So like 1 billion years is how long this takes for the timescales that are far out. Yeah, so that's how long.
Casual 1 billion years.
Yep, we astronomers, we just throw around billions of years like it's nothing.
Wow.
Thank you.
Thanks, Alex.
Okay, up next, we have the Cosmic Kid with What's Up? So let's welcome the Cosmic Kid. What are you drinking tonight?
I am drinking a wonderful glass of bourbon. This is actually my third glass, and I use the term glass very liberally, so this is going to be fun. So welcome to What's Up? This is the monthly segment where I share with y'all what's up in the sky, what's fun to observe, what you can do. And I've split this in a couple of different categories based on the difficulty of observing. There's plenty of stuff that just starters can do, so it's pretty great. So first of all, let's talk about what I consider to be the easy peasy things to do, right? And the big ones are the planets. So there's the big 5 planets is what I like to call them. I don't know if other people call them that. But these are the 5 easiest things to view in the sky for beginners. You can view these easily with your naked eye or with a small pair of binoculars or a telescope. You don't even have to leave town to see these really well, honestly. Now, Mercury's not up around this time of year, so just forget that. Throw that out the window. Venus is going to be really big and bright in the east just before sunrise. It's going to be the brightest thing in the night sky other than the moon. Most nights, actually, it's going to be brighter than the moon because the moon, new moon, crescent moon, all that stuff. But Usually it's the second brightest thing in the sky. Mars is also a pretty easy thing to see. It's gonna be big and bright, and you're gonna look late at night, somewhere around 11 o'clock midnight is probably the best time to start looking for Mars. And it's actually closing in on opposition, which is when it's gonna be the closest and biggest and brightest to us. That's gonna occur really at the end of September, beginning of August, but it's starting to approach that phase, so it's gonna look really nice in the sky right now. Another great thing to look at is Jupiter, which is going to be big and bright, and it's going to be up all night long. Hence, you can party all night long with Jupiter. One of the fun things to do with Jupiter is you can actually see 4 of its moons most of the time with a small pair of binoculars and a small telescope. These are the 4 Galilean moons, and they actually orbit so fast around Jupiter that you can watch as they move across Jupiter over the course of a single night. So that's a fun thing to look out for. Saturn is also another really fun object to watch. It's also up all night. It's actually trailing behind Jupiter by about 8 degrees this month. So if you wait a little bit next to Jupiter, just to the east of Jupiter, you'll be able to see Saturn pretty easily. And it's pretty much the next brightest thing in the sky in that area. So it should be pretty easy to spot. Next, if you want to level up and try something a little bit harder, the Milky Way, this is a great time to try and view the Milky Way. So the Milky Way around this time will stretch all the way across the sky from the southern horizon, across the eastern sky, and into the northeast. To view the Milky Way properly, what you want to do is get out of town, grab some smooth jams and relax, because it's going to take a while for you to adjust to the darkness of the sky. And you want a really dark sky to see the Milky Way, because it's not very bright compared to, the skylights and stuff that's always around. And it might take you a while to adjust. And really what you're looking for is a fuzzy blob that'll stretch around the sky. It's not going to look like this image right here in your eye. It's going to look more like just a fuzzy kind of bright splotch across the sky. But if you do have a camera that's able to take high exposures, you can get beautiful pictures like this. So the Milky Way is a great target if you're interested in starting astrophotography, for instance. Now, this is what it gets through the challenge mode. This is the hardest thing to look for in the sky. But honestly, this month's target isn't even that much of a challenge to find. It's the double cluster, which is 2 open clusters that are relatively close to each other. This is NGC 869 and 884. Now, where you want to look for this is going to be in the constellation of Perseus, kind of in the northeast of the sky. And the clusters themselves are considered to be the jeweled handle of the sword of Perseus. So that's kind of a fun thing to look for. You're going to want to look at this pretty much any night, but it's best viewed around midnight. And you want to go to a dark site. You can find it with the naked eye, but you're not going to be able to see the individual stars in the cluster makeup unless you have a pair of binoculars or a telescope. And why should you look at it? Because it's super, super cool. I mean, it's a double cluster. It makes the sword of Perseus. How much cooler does it get? And that, my friends, is what's up.
Foo Fighters, yay.
I was just thinking about this. I don't know if you know this, but if you have a Google Pixel, there's an astro photography mode or something like that. And it kind of takes longer exposures if you're out and looking at the sky, and then you can see more stars in the view.
Yeah, so a lot of cell phone cameras these days, you can actually adjust the settings, including the exposure and stuff. And in the top end models, like the Google Pixel and the iPhone, actually have a specific astrophotography mode. I've taken a lot of pictures just sticking up my cell phone up to the eyepiece of a telescope. It's hard to keep it steady long enough to take a picture, but you can. And you can also prop it up against a rock and take a beautiful exposure to the night sky, which is also something I've done. So if you want to get started in astrophotography, your cell phone is honestly a pretty good place to start.
Cool.
Kid.
All right. Forgot to mention, gonna take a sip of beer. And since I'm doing that, a reminder to tip your bartenders. If you'd like to tip our regular venue, the Grand Stafford, the link is in the description of this video. That's the YouTuber thing we forgot to say at the start. Apologies. All right. So next up, we have Dark Matter Dude with Astronomy in the News. And spoiler, Beetlejuice is back.
Did you miss me? Yeah. So I'm back. So we're back. We're gonna talk about some news now. Cool. Right. So, it's not letting me do that. I'm a little more tipsy. The Moby drink is hitting me now. So let's do this. Right. Okay. So Perseverance launched. This is a fantastic thing. We were kind of worried about this. I talked last month about how I was worried about this, and everything's fine. It's all great. So Perseverance launched July 30th. It will Perseverance is the next generation Mars rover, and it is going to arrive February 18th, 2021, which sounds like a long time from now, but really like isn't that much. So that's pretty cool. There was some concern about the launch window was only like 2 weeks. And so that's not a lot of time to launch something. And that was mainly set by Mars's orbit relative to Earth's. So right now, Mars and Earth are actually very close together. And so that's why all these different countries, I forget which countries now. There are a whole bunch of different countries, lots of Mars missions are being launched right now. Just because Mars is close to us right now, and it won't be for another like 1.5 years or 2 years. So that's why there's a lot of Mars news right now. Perseverance, once it gets to Mars, will search for life conditions. It's going to work a lot like Curiosity does right now. And so it's doing things like taking soil samples, atmospheric measurements, etc. To try and see if they're good enough conditions that it could have at one point in time hosted life, or maybe even possibly now. Two of the really cool ways it's doing this, it has a microphone, which is the first time that we're putting a microphone on something outside of Earth. So that'll be fascinating. They'll turn it on as it's landing, so we'll actually hear what it's like on Mars. And there's a freaking helicopter on this thing. So it has to be very lightweight. It's called Ingenuity. Yeah, it's gonna do a whole lot for atmospheric measurements and taking a whole bunch of really nice pictures. So Perseverance, great. Hubble detects life on Earth. Hey guys, there's life on Earth. Yeah, so we're gonna take a step back. During a planetary transit, which is how a lot of exoplanets have been discovered. So when a planet passes in front of a star and we see a dip in the brightness of that star, that's how we know there's a planet there. During a transit, the atmosphere around the planet actually lets some of the light through, okay? So if you take a spectrum of that light, disperse that across a prism, basically just like the Pink Floyd album, you can use that spectrum to measure things like how much oxygen or ozone is in the atmosphere. So all of this is pretty theoretical, but people are pretty convinced that you can do it with future instruments for other exoplanets. But you can test this method on Earth using the moon. So the idea is to point Hubble at the moon, which is really hard. We'll get to that in a second, during an eclipse, during a lunar eclipse. So when Earth is between, I hope I got that right. When Earth is between the sun and the moon, light passes through Earth's atmosphere and then hits the moon. That's why it looks red, for the same exact reason that that sunrises and sunsets look red. And so if you point Hubble at it, take a spectrum, you can use that spectrum to detect oxygen and ozone, which are some of the primary signatures of life. And this is really hard to do because Hubble wasn't built to point at the moon. It was built to point at things that are very far away, that aren't moving very much. So it's actually very hard to track. These were a couple of the observations. The black star is where nominally it was supposed to be, and then it was bouncing around a lot because it's really hard to point Hubble at the moon. It just is. So yeah, so that's neat. Basically, so we found ozone and oxygen in this spectrum, which means two things. One, there is life on Earth. Got it. Two, we can with future telescopes, we could probably do this. For other planets orbiting around other stars. That's cool. Betelgeuse, right? Okay. So Betelgeuse is a star, a red supergiant, that a couple months ago was doing some really weird stuff. It got very, very dim over the course of just a few months. It basically just shot down in how bright it was over time. And that was really weird. Betelgeuse is a variable star, but that's different from what everyone was expecting. It happened very, very quickly, and it dimmed to roughly 70% of what it normally is. That's weird. We finally have a pretty good explanation why. It's because it burped at us. So the general idea here is that being a red supergiant has a whole bunch of weird variability going on. It basically, the Betelgeuse released a clump of gas that initially was very hot, like emitting X-ray level hot, and then eventually got as it went away from Betelgeuse, it got cooled down, and then as a result, blocked some of the light that we were getting from Betelgeuse. So there's a schematic of that showing up in the first 3 panels, and then the view directly from Earth, you just see a shadow. You would basically just see a shadow blocking Betelgeuse, which is very consistent with observations that we've had before. So this is the idea. This is pretty much the final explanation for why Betelgeuse got very dim very quickly. Yeah, so this makes sense. It's great. If you don't like the burping analogy, you can also use the farting analogy. Works just as good, I promise. And you get the Monty Python joke in there too. Right. So this next bit, this is less fun, but we're going to talk about retooling that's happening of the NSF, or the National Science Foundation. It's going on right now. So there's 2 parts here. Part 1 is Congress is currently taking up a bill called the Endless Frontiers Act. And so there's good parts of this bill. It wants to provide an additional, on top of what the budget already is for NSF regularly, it wants to provide an additional $100 billion over the course of 5 years, which would be a 240% increase in NSF's budget. That's huge. It's a really big deal. But there's a caveat to this that a lot of scientists aren't very excited about. There's a new focus that's being put on the agency, and it's focusing on commercial and technological innovation. And that has a lot of scientists feeling a little weird. There's also the NSF's Graduate Research Fellowship Program, which I am actually a member of. This is who paid, the NSF cuts me a check. That's how I get paid. I get paid to do research through the NSF, through this program. The GRFP recently put out its application for next cycle, and in it, they included this kind of distressing language about putting high priority on artificial intelligence, quantum information science, and computationally heavy projects and ideas. And the reason that a lot of scientists are kind of concerned about this is that the NSF, in principle, in its foundation, is supposed to fund basic research, basic science, that for which the commercial or technological applications for it aren't straightforward or clear. It's how you get a lot of innovations that will help society in the long run, but it isn't obvious right away. We're not doing research to like make a better supercomputer or do something like that. We're just doing science that is interesting and pushes the frontiers of what humans know. The NSF is really one of the only institutions that does that. There are lots of other places that academics get funding from. So like the Department of Energy, some others that I'm sure exist, but I can't remember. But those are generally tied towards particular goals that have to do a lot with defense, some other stuff. And the GRFP in particular, the Graduate Research Fellowship, is really supposed to fund, it's kind of a cool program in that it funds the scientist, not the project. So if I, Alex, decided I didn't want to do what I do right now, cosmological simulations of dark matter, I could do something else and keep my fellowship pretty much no questions asked. So the fact that they're tying this initiative to a particular subfield, and that subfield corresponds to this kind of commercial and technological innovation, has a lot of people kind of freaking out. So this is something to keep your eye on. We'll talk more about this as in the coming months as we learn more. The last thing is just really cool. I got nothing else for this. So basically, this picture was taken by McDonald Observatory. That's the observatory in West Texas that I talked about 15 minutes ago. And so this is a really cool image of what's called a jellyfish sprite. And basically, this is a thunderstorm that is interacting with the Earth's atmosphere in a really weird way to give you something that straight up looks like aliens. And so this kind of reminds me of all these times when people talk about seeing aliens or seeing something weird in the sky. You know, the sky doesn't need aliens to give us some weird stuff. Nature can do that all on its own. So yeah, that's the in the news.
Thanks, Dark Matter, dude.
And that's the tea.
Yeah, kind of bummed out about the NSF stuff, but Yaswant and Derek did point out a silver lining in the chat. Yaswant noted that if it's over 5 years, is it really endless? And Derek suggested that it be renamed the Relatively Large Frontiers Act instead.
That's good.
We could suggest that. Call your representatives.
Yep.
Call them generally, actually. Good habit to maintain. Anyhow. So on to our final speaker of the night.
All right, so presenting our second speaker tonight, Micalyn Rowe. Join us, Micalyn. So she is a second-year graduate student at Texas A&M as well. And a boring/fun fact from Micah, Micah's her nickname, is that her personality is exactly like her dog's personality. Did I get that right?
Yeah.
Yes. Are just essentially the same mammal. But yeah, that's a beautiful relationship to have with your dog for sure. All right, welcome, Micah.
Okay, let's get started. Okay, hey guys, good evening. My name is Micalyn Rowe, like Sylvie said. I'm a second year here at A&M, and tonight we're going to be talking about something called Archaeoastronomy. So some of you may be wondering, what is Archaeoastronomy? So Archaeoastronomy is simply defined as the investigation of the astronomical knowledge of prehistoric cultures. So we pretty much look at these prehistoric cultures and we see, hey, can we see that, they looked at the stars? Can we tell that they looked at the stars from drawings, looking at alignments between buildings and, different ways that these past cultures have built certain structures and everything. We look at that and see, did it line up with anything in the sky? And just a quick tidbit, this is actually a course that was offered at my undergrad institution, Texas A&M University in Commerce. And it's a really cool subject, really amazing teacher. You get to travel to different sites. We got to go to Chaco Canyon, and we also got to go to Mesa Verde in Colorado. And yeah, so if you're at Commerce, take that class. It's awesome. And then just another side note, this picture in the background for this first slide, this is going to be a picture of Costa Rinconada in Chaco Canyon, which is one of the places that we visited. And so, yeah, it was super fun, and we got to go see it. Okay, so the first thing that I wanted to show y'all and talk to y'all about was Stonehenge, and this is located in the United Kingdom. It's a pretty famous, kind of historical landmark. This was built around 3000 to 2400 BCE. And then just wanted to talk a little bit about the structure. So these outermost stones here is called the Sarsen Circle. And then it's kind of like a horseshoe shape. These are called the trilithions. And then this altar stone, you can kind of see it here in the middle. This is called the altar stone. And it's not shown in this picture, but like farther out in like the field that surrounds this area are these like weird little holes in the ground that are filled with chalk. They're filled with chalk now. But before, they used to be, they tested the substance that was in the holes, and it was actually cremated remains that was in these little holes. And then one more thing I wanted to mention was that's kind of important for the structure is way out here in the upper right-hand corner, like, you know, past the what you can see in the picture, there's this thing called the heel stone. Okay, so this heel stone is actually kind of important for its like astronomical aligning. So if you sit at the altar stone, which is like in the center of Stonehenge Circle, and you look towards the heel stone on the summer solstice during sunrise, you can actually see the sun, as you can see in the picture, rising right over the heel stone. And you can also, vice versa, turn around and see it during the sunset on the winter solstice. So like that's one astronomical alignment that we have seen in, you know, past cultures. But however, most of us know about Stonehenge, but we don't know about the other structures here in the United Kingdom. And so this structure actually wasn't alone. There was something they called Woodhenge, which was around this area called the Durrington Walls. Obviously, it was made out of wood, so it didn't preserve as well as these stones did. And the only reason that they knew that this kind of Woodhenge existed is because, of course, digging up some of the remains. And so here's a map of kind of the geography of Stonehenge relative to Woodhenge. So Stonehenge, as you can see, is kind of here in the center. And what would happen is ancient peoples would make the trek along this road called the Stonehenge Avenue down to the river. They would follow the river and then come all the way up here near this Durrington place. And then they'd walk up Durrington Avenue, and then Stonehenge was in this area. And so Durrington Walls is literally just a big circular trench around this area. And then another weird thing that they found was this thing called the Greater Cursus. And so this was just a big rectangle carved out of the ground. It was there, and it was like a significant landmark. And so that is Great Britain. And so there's also another site in that area of the world. It is called Newgrange. It's in Ireland. And this is a burial mound that was built around 3100 BCE. And so it's just a big mound that rose out of the ground. But this mound is actually hollow, weirdly enough. So as you can see kind of out here in front, you'll see here, these little stones here are going to be called curbstones. And they were like elaborately curved, carved stone that was carved with spirals, and they were like lined up in the front. And so here is an image of kind of what the inside of that mound looked like. So if you look at it from the top view down, it kind of makes this cross structure, and it's not lined up perfectly north to south. And we'll find out why in a second. And so, yeah, in this, and then here on the bottom is a side view if you were looking in. Okay, so looking here at the top view, it actually points in the southeast direction. And what happens is on the winter solstice sunrise, the sun actually streams a beam straight through this tunnel. And then also, like I said, this was a burial mound, and so there had to be some bodies in there. And so they put those remains in these wings. And so from the side view, the important thing is that it weirdly enough sloped upwards, this tunnel does. And so how the sunlight reaches inside the tunnel is there's this little thing right here that's called the roof box, and it allows the light from the winter solstice sunrise to reach the back of the tunnel, and it lights up during the solstice, and it's really, really pretty. So the next thing I wanted to talk about is the pyramids that are in Egypt. This is just a little fun fact. All the pyramids are actually on the west side of the Nile. And that's because like in Egyptian culture, the west side represented death because the sun sets in the west. And since the pyramids were used to bury the pharaohs, it was kind of symbolic. So first they used to try and bury the pharaohs in these things called mastabas, which was an underground burial chamber. You know, it's like it made like a little mound in the ground. They were hard to tell what it is. But eventually they started to move to above ground burials. Okay, and so in this picture, these are actually the Great Pyramids of Giza. And like I said, the entire reason for these pyramids was to get the pharaohs to the afterlife. And the attention to detail, building these things in the first place with the technology that they had available, what seems insane in the first place, but their attention to detail was crazy. They were insanely precise. They actually used to just use one stone called the cornerstone on the southeast corner of the pyramids to line up the entire rest of the pyramid with the cardinal directions. And so they lined it up really nicely, north, south, east, and west. And so they didn't just line up the outsides of the pyramids or the sides, they actually lined up the inside of the pyramids with certain stars. So this is the Great Pyramid of Khufu, and we're looking at the interior structure. This pyramid was built in 2554 BCE, and the entrance was on the north side. And like I said, the most interesting thing about this is the interior alignments with astronomical objects. So this bottom left shaft here, this shaft actually points to Sirius. Some of you might know it as the Eye of the Dog, which is Canis Major, and then also it's the brightest star in the sky. And then this top left air shaft here actually points to Orion's belt. Orion is a well-known constellation in the sky, you know, the 3 stars. That air shaft actually points directly at that his belt. And so this top right air shaft here, this points to something to a star called Thuban, and this at that time was their North Star. And then this is also, it's a weird fact, but I like the name of it. It was also known as Alpha Draconis. That was another name for Thuban. And then this bottom right shaft here actually points to a star called Kochab. And this is the brightest star that's in the bowl of the Little Dipper. And the Little Dipper is also known as Ursa Minor. And so somehow, planting this huge pile of rocks and stone, they were able to create these chambers, these air shafts that actually pointed in the direction of these stars. And so we're going to move a little further east for this next point, and we're going to talk about this astronomer, Gao Shoujing, and of course he's from China. He actually was a Chinese astronomer, and he built something called the Gaoqing Observatory. And this is what it looks like. He designed this observatory in present-day the Henan province in 1276 at the beginning of the Yuan dynasty. This building is about 30 feet high, and this trench right here, this trough, is actually like 100 feet long, and it's built out of stone. And this, as you can see, this kind of dip here, there's like a trough that they would put water in, and that's how they would actually make sure that this entire thing was level. And this path being level was actually important for the measurements that they were making with this. And so what this observatory does is it measures the sun's shadow, as you can kind of see here on the right side with this drawing. And it pretty much acts as a huge sundial. And so the bigger that they made these sundials, the more accurate they could be, like telling time. And so they just made an extremely huge sundial. And so we're going to move a little further east. We're moving east in the world and talk about just briefly the wayfinders from Polynesia. These Polynesians, they would sail huge distances and would navigate the Pacific Ocean, you know, from places like from Hawaii to Fiji. And yes, like the movie Moana, their navigation techniques, they used stars, currents, waves, and also birds to find islands. And they had a very specific technique to kind of measure where they were at with the stars. What they would do is they would sail, they would aim not directly at the island, but a little bit east of an island. And then once they hit the correct latitude, they would then travel straight west until they hit the island. And so remember, latitude is the measurement north or south of the equator. So it's pretty much like how far north or south you are from the equator. And so what they would do is, you know, they use a hand technique to kind of measure, you know, how far the star was from the horizon, and that's how they could tell their latitude. And so now we've finally hit North America. This really cool place is called Chaco Canyon. It's in New Mexico. It was built by the Anasazi people. This name was given to them by the Native Americans, and this actually means ancient ones. So they were here before the Native Americans. They think this was built about 950 to 1150 AD. And then this picture that you'll see in the background, keep this in mind for a later slide. This picture is the Fajada Butte. And yeah, like I said, remember the structure later. This next photo is going to be one of their structures in Chaco Canyon called Pueblo Bonito. And they really, really aligned this with cardinal and astronomical directions. And so here they had something called a meridian wall that was aligned north to south. And then the kind of structure of this is where they lived, it's kind of these outer portions near the arch was actually kind of built like a staircase. And then the exposed rooms, you know, kind of the top of the stairs were used for, you know, living in shelter. And then the bottom rooms are actually used for storage. So these big round dips in the ground, they used to have covers on them, wooden covers, and these are going to be called kivas, and they were just like a gathering place for the Anasazi people. And then the wood that they actually used to build these structures is how we were able to date when this was built. And fun fact, like I said, I actually got to go here and explore the area. And they have really short doors. Like I'm 5'1", and the doors were even shorter than I were. So they must have been really good at bending over. And when they left this settlement, they actually bricked in the doorways. And so we came back to it later and we were like, where are the doors? Well, we were able to find the doorways by the different types of stone that they used to fill it in. So this next structure is known as Casa Rinconada. This was actually, this is a different shot of the slide that I showed on the very first title slide. This was also known as a house with no corner. This is known as one of the Great Kivas, and this was a decent distance away from Pueblo Bonito. And you can see the structure here. We have 4 wooden post holes where they had, where they put their big wooden columns. And they had niches in the walls to hold the wooden floors up. And then on the summer solstice, there's a window. You can't really see it here, but on this kind of top right, not corner, but top right side of the Casa Rinconada. And on the summer solstice sunrise, the window actually lets the summer solstice sunlight shine through. In this last picture here, remember I told you to remember the Fajada Butte. So they leaned big stones up against the edge of the butte, and they carved these spirals into the side of the rock. And what happens is on the equinoxes and the solstices is they have these light daggers that line up with different orientations on the spiral. And I'm telling you, these stones were huge. It's crazy how they managed to move them. But as you can see here on the left, this diagram, of how these light daggers would hit the spirals at different events. And then this last one, I actually got to hike and go see this hieroglyph, or this petroglyph, and it was preserved beautifully because it's actually on the ceiling of kind of a cliff overhang, and so, you know, erosion, wind, rain, it didn't wear it away like it has other petroglyphs. And then we think that this depicts the 1054 AD supernova. This is when the Crab Nebula blew up, and we think that this is what that's depicting. And we know that a supernova happened on this date because Chinese astronomers actually saw and recorded the date that this happened. So that's how we know it happened. And getting close to finishing up, we are moving a little bit south and looking at Mexico. This place is called Monte Alban. It was created about 500 BC. It was at a very high elevation, and they actually built a zenith chamber with a zenith tube. And what a zenith tube is it means a zenith is the highest point. And so when the sun gets to the highest point in the sky directly overhead, what happens is the sun shines straight through this tube and usually illuminates like an altar or petroglyph or something in a chamber underground. And so another interesting thing that they had here is they had a special pentagonal building they called Building J. And you can see it over here on the left. All of their buildings were aligned north to south, east to west, except for this weird 5-sided building. And so what they found out is the building that held the zenith chamber, when you line up this and the pentagonal building, it actually points, and you can observe the star Capella. Now, Capella is a star in the constellation Auriga, which is also a pentagon. And so they think that this may have had like a significance to their culture. And so, yeah, it was really cool. Another interesting site in Mexico is Teotihuacan. This was built around 100 BC. It means city of the gods. And this structure actually predates the Aztecs. This road isn't actually straight north to south, but this road is called the Avenue of the Dead. The orientation of the pyramids is kind of weird to me because I would expect the biggest pyramid to be at the end of the road, but it's actually not. The biggest pyramid, called the Pyramid of the Sun, is over here in the top right corner, kind of on the side of the road. And then this pyramid at the end of the road here is called the Pyramid of the Moon. The north side of the Sun Pyramid lines up with the sunrise on February 9th and November 2nd. And then for sunsets, it's April 30th and August 13th. Another site in Mexico is Tenochtitlan. This was built around 1325 AD. It was built on Lake Texcoco, where the Aztecs built this. And their beliefs said that they should build a city where they saw an eagle eating a snake on a cactus. Just super specific to me. And they said if they built a city where they saw this, then they would be a great empire. And as you can see from the picture, they were very organized. All the roads were lined up with the cardinal directions: north, south, east, west. And you can see the center plaza that they had here. Of course, they wanted to line it up with, a special sun event. And so this blue temple is going to be the temple of Tlaloc. And this red temple is the temple of Huitzilo. And that was the god of sun and war for them. And so this entire temple here, the big temple altogether, is called Temple Mayor. And from this viewing platform that you can see right here in the center, if you stood up on the top of that, on both of the equinoxes, fall and spring, then the sun will rise directly between these two temples here. And the last site that we're going to kind of go over is Machu Picchu, which is in Peru. This was created by the Inca, and it was found by Hiram Bingham III when he was on an expedition to find Incan cities. This was actually in use 1438 to 1472. It really wasn't in use that long, but it was used as a summer palace for their emperor Pachacudi. And then one building in particular was really interesting with its alignments. This building was called the Torion, and the window casting the shadow points towards the rising of the Pleiades. And then this window here on the right, you can kind of see me circling it, points to the rising of Kalka, which is the last two stars on the tail of Scorpio. And so last but not least, I didn't have very many slides about this. I didn't get to add it, but this was a site in Mesa Verde, Colorado that we got to visit with my class, and it was super cool. They built their shelter under the under cliffs, which seems really dangerous to me because of rock slides and everything. But they made it work. They made it safe, and we got to hike and see these things. So that was super cool. Please let me know if you have any questions in the live YouTube chat. They'll let me know. And it seems we already have some. And so, and just for the purposes of having it, if anyone's interested in the pictures, I want to get it on the YouTube feed. Here are the references for all the pictures that I used. And the references correspond to the numbers in the bottom left of the pictures that I used. And so there is some artwork. If you like some of the pictures, you can buy them from these sites. So on to questions. So Sylvie, do you want to take over questions or do you want me to read them?
Oh, we got it. MCM 33.
So this first question comes from the Cosmic Kid. The structures were built long ago, and the position of stars relative to the Earth and the orbit/tilt of the Earth has changed ever so slightly. Do the structures still align with the heavenly objects today?
They don't, and that's because of something special called the precession of the Earth. So it's like we have the alignment. We have different North Stars. The North Star, 1,000 years ago or so, was Thuban, which I mentioned, the Egyptian pyramids aligned with. But now, of course, a lot of us know it's the North Star's Polaris. So it's because of something called the precession of Earth's axis. So.
Oh, okay. This next question comes from JHC. Are there any hypotheses as to why they put the Temple of the Sun off to the side instead of at the end of the Avenue of the Dead?
Honestly, I don't know. That it weirded me out also. And I was like, this doesn't make sense to me. I want the big thing to be at the end of the road, but they didn't ask me or consult me when building it. So yeah, I have no clue.
Who knows, right? Made so long ago. These are phenomenal structures. It's incredible. And it's so cool that you actually got to visit some of these sites.
Yeah.
Yeah, I got to visit Mesa Verde, like I said, and Chaco Canyon. And when I was little, actually, my parents, I didn't appreciate it at the time, but they took me to see Teotihuacan. So that was really cool.
Wow, amazing. We have a couple more questions.
Yeah. This one comes from Cosmic Strings. My wife wonders if there are anything in Australia that has been discovered.
So a lot of this information I got from my class because, yay, class is learning. But as far as I know, no, but I could be wrong. I'm not an expert in this. But I can get back to you, Dark Matter Dude's wife.
Cosmic Strings, actually. Cosmic Strings.
This next one's from Josh Willis. Which structures were built by aliens?
Well, I'll let you answer that one yourself. You researched. Yay, learning.
In the search for aliens, ask them these questions. Well, thank you so much, Micah. That was an amazing talk.
Yeah.
Thank you for having me.
All right, we are getting close to 8:30, so I'm going to speed through the answers to trivia. So if you've been following that, now you get to know how you did. Okay, so this month, for no apparent reason, trivia is no comet. Pick the right answer. So question 1, which comet is visible from Earth every 75 years? It is Halley's Comet. Question 2, which comet is visible from the Earth every 2,500 years? That would be Hale-Bopp. I've always liked the name. Question 3, which comet was involved in the first observation of solar system objects colliding? That would be the very dramatic Shoemaker-Levy 9. Question 4, you can tell the person who made trivia was feeling a little bit silly. Which is one of Santa's reindeer? Keeping with the theme, comet. Question 5, which spacecraft passed through a comet's tail? That would be Giotto. Question 6, which spacecraft landed on a comet? The answer is Philae. It was actually carried by option A, Rosetta. Question 7, which spacecraft collected material from a comet and shares its name with the Neil Gaiman novel? That would be Stardust, which is looking very cool in this artist's impression. Question 8, so you saw this comet already. Which planet did the fragments of Shoemaker-Levy 9 crash into? That was Jupiter. And it's really cool that like the brown spots that you see are actually where the pieces of Shoemaker-Levy 9 impacted. Question 9, which American astronomer was awarded a gold medal from the King of Denmark for discovering a comet? That would be the very cool Maria Mitchell, America's first woman professional astronomer and astronomy professor. She taught at Vassar College. And question 10, last one. Which comet was visible from most parts of the US this summer? Neowise, a very pleasant, cool surprise. Got to drive out with some friends and convince ourselves that we saw it, which we only really confirmed after we brought along someone with binoculars. Because from Texas, yeah, it wasn't easy to see with the naked eye.
So you were able to catch a glimpse?
Yes, I was certain that I saw it after I confirmed with the binoculars. Otherwise, like a smudge. I think I see it. And then all four of us could see the smudge. So we're like, okay, that's probably it. But be nice to confirm.
I was not able to see it, but it's okay. All right, so wrapping it up.
Yeah, we've got our usual announcements that I would love to pull up if my computer lets me. There we go. Okay, and we gotta back it up, close your eyes. Okay, again, like and subscribe to our YouTube channel to be notified about all the things we're doing.
And like us, follow us, support us. Go to our social media. If you don't have Twitter, make it. But you will find all of the news and the events that are happening coming forward. So make sure to do that.
All right, please help support our usual venue, the Grand Stafford Theater, to tip your bartender and help them out. You can Venmo at Jose-Quintana-20 and put Stafford Tip in the description so he knows what it's for.
And also support your grad students, Texas A&M graduate students who are able to make this possible and give us a little donation. And again, this is via Venmo or Cash App at AoT BCS. And with $15, I'm just going to show you guys one more time, you can get this cool shirt, which I love. So make sure to do that.
All right, and last of all, our next event is going to be on September 16th. That's the third Wednesday of the month. Same time, same YouTube channel. And before I forget, like I forgot last time, all the links to what we just shared are in the description of this video. So with that, Can I
We
leave?
will see you next time. And thank you all for joining us this evening. And thank you to the speakers. And just thank you, everyone.
All right. Have a good night, everybody.
Good night.